Hi, this is Mohammed. Now I was going to explain big data analytics and application ICP6. Let me share my screen. So this is the code. So actually what I need to do is my ICP6, I need to perform the text generation by using the LSTM layer. Okay, first what I was doing, I was importing the libraries, required libraries, and then I was uploading the data which I downloaded from the browser. So this is the data I downloaded, and then I was uploading into Google Colab. So the next command what I was doing, I will be reading the data, and I will be printing the length of the data. So length of the data, so how many characters are there? So you can see 21,67,737 characters are there. So in the next command what I will be doing, I will be printing the first 250 characters. So here you can see the next one. I was just taking the unique characters from the text data. So what I'll be doing by using the set is a predefined function in Python. So here and then the text will be in the sorted order. So finally I'll be having the unique values, unique characters 46. So next what I'll be doing to perform this model, my data should be in the form of numbers. So what I will be doing, I will be vectorizing this data. To vectorize this data, actually my data is in the form of characters. Now I need to convert into numbers. So what I will be doing is by using enumerate function, I will be I will be generating a mapping function like dictionary. So it will be like key value page. So it will be converted character to index. In the same way in p.array vocab. So here the index will be converted to arrays, and here the next one, what I'll be in p.array character to index. So here what I'll be doing, my text is in here, it is the data. So by using the key for C in text, I will be converting the text, entire text, the 21 lakh text into the values. So here I had printed the and printed character 2 index. So here you can see the key value pair. Right now, next step what I will do to perform this training. So what I need to do is to train this model. Here what we'll be doing, here I had given you the example. You can see the data actually that is hello. So what I do is I'm giving the input sequence as a hello. So the first four characters I will be HELL, and then what my prediction, what my output will be, it is ELLO. Means it should be four characters with the last exceeding index. So this is the task I need to do, and then after that I need to generate. I need to perform the text generation from where I need to from I will be giving certain word, certain text. From that it will be the printed. So you will see later here. Right now what I will be doing is, as I mentioned, our data is having nearly 21 lakh characters. So what I will be dividing that 21 lakh into subset into means some elements. So my each element will be having 100 characters. So in that way I had divided, and then what I was slicing that the text as int, and then I was printing. So here actually my text as int, it will be having the numbers. So here as per the key value page, so I will be getting the characters here. And then next here what I will be doing is, I will be converting this individual character to sequence of desired size. Okay, here you can see as I explained, as I give the sequence length equal to 100. So in this way, my sequence variable will be having all the data, which is each element is of 100 length. Okay, and then next what I will be doing is, I will be, you see, this is the function how we will be performing this task. So as I mentioned, hello, the first four characters is the input, and then it will train them out, and the output will be ELLO. So in this way, the output in this way that we had defined the function, and I had used that function as a parameter, the sequences, and then that data will be stored as a entire data set. So finally my data, the final data set will be having the input and output. So here I will just printing one example. We can see that. So this is my input data and what the target data should be. So here it will be exceed the one character at the last. Okay. And then I was creating the batches here. So batch size batch size I have given it as 128. So batch size for each iteration I will be having 128 128 data, 128 characters. So in that way I had given the batch and the buffer size. Buffer size it will shuffle the data set. So buffer size is equal to 20,000. And then next time what we'll be doing here, I will be building the model. So actually, to train the model, we need to use LSTM. So in this way, for LSTM, we'll be going some depth into the layers. Actually, RNN recurrent neural networks. So we'll be going this LSTM is the specified version of the RNN. So here we will be having 3 layers. So embedding means the inputting layer, here the how many the RNNs we are using, and then it's the final layer. So here we had given the parameters, and then I had defined the model, and I had defined the functional build model. So actually I was passing it as these relays, and with respect to the parameters here you can see, and then I was also adding the dropout layer where the 20% of the data will be lost, and then finally the dense layer, and finally building the model. So here I was calling that function, and I'm running the model to see the behavior, how it will be, how my output will be accepted and expected. Okay, so here in the same way I had done, I will be getting my output as a 120 as a batch size, 100 as a sequence length, and 46 the unique unique characters. This is my endeavor, and this is my summary. Here you can see embedding the 3 layers, embedding LSTM and dense. So here I was predicting the model. So here you can see that one. And finally, I am training the model. And then I was compiling the model with the optimizer equal to Adam. Then loss by and also with the loss function. So here I had given the loss. I would define the loss function, where we'll be putting the prediction shape and the scalar loss. And then so here we are configuring the checkpoints. This is the folder when you will be building this one, it will be stored here. So finally you are executing the model epoch equal to 10. So here you can see that 10 passes you will be having, and each batch will be as I said, so each batch will be how 128 we are different. So each 167 each will be having the 128 as a data. So it will be executed, and you can see the loss function goes on decreasing. So that means our model is executed perfectly. So actually I had before I had used RNN. So RNN, and I didn't use any of the dropout layer there, and also the parameters I had changed, so that everything I had mentioned in the document. So when I was using RNN with some modified parameters, you can see here, you can see in that document not a much difference, but when I was using dropout, it is somewhat better than that approach. So this is the observation I found. And finally, finally for generating that text, I had generating that I had in the following I had defined the function, so that can generate 100,000 up to 1,000 characters. So this is the function where here we will be doing, we'll be generating that text. Then finally I will be printing the data, which will be starting from none laboratories. So when I executed, I will be getting up to 1,000 characters. Thank you.